Okay, so final video, and we're looking at compound inequalities using OR. Now, when we're talking about compound inequalities using OR, we do not need to satisfy both inequalities. We need to just include values that work for one inequality or the other. Okay, not both. So what does that look like? So our first compound inequality is x is greater than 4 or less than -7. Okay, so let's graph each of these. So x is greater than 4 is going to look like this. Wow, that's a funky line. And x is less than -7 is going to look like that. Actually, let me graph that in a different color. Okay? Now, when I graph my compound inequality below, I am only going to select values that work for one or the other. So the only thing I'm not going to select are values that don't work for either, which means I'm not going to select any of these values here because they don't work for either inequality. So my compound inequality graph is simply going to be this. Okay, all I'm doing is combining the two separate inequality graphs that I did here onto one graph. Now I'm only able to make two number lines in this app. In an ideal world I would have three, one for each single inequality, one for the compound, but I don't have that. So down below we have our graphed solution, and we don't have a fancy way of combining them like we did with the intersection compound inequalities using AND. So the solution is the same as what we started with, and this is how it's graphed. Okay, so let's take a look at another example where there's something different going on here. Okay, so we're looking at the second one. We have x is greater than -1 or x is less than 6. So let's start with the first one. X is greater than or equal to -1. There we go. And x is less than or equal to 6. There we go. Now, remember that down below we are only going to graph the numbers that work for at least one of these inequalities, these. So what we're not going to graph are numbers that work for neither of them. Are there any numbers in this image up here, the first number line, that are not included for one inequality or the other? No, there are not. So what this means is that our graph is going to look like this. The whole number line works. Each one of these numbers going off in infinity to both directions will work for either this inequality or this inequality. So our solution at this point simply becomes all real numbers. Okay, this is very different from our AND inequalities, because our AND inequality would have a graph that looks kind of like this, right? That's for the AND, but we're not dealing with AND inequalities, we're dealing with union sets with the word OR. So it's different. With OR is what we have in blue here. Okay, so let's get rid of all of this and work on the next one. Okay, so we need x is less than 5. All right, so x is less than 5. Like that. Or x is less than or equal to -3. Like that. Now, we need to graph all the values that work for at least one of these. Or in other words, we're not going to graph any values that work for neither of them. Now, the only values that do not work for either of these are 5 and up. They don't make either of these inequalities true, but we can graph everything else, which means we're going to end up graphing anything less than 5. And so the solution to this inequality, because all of these values here Well, they make both inequalities true, but these values, up to but not including 5, they work for the one inequality, the x is less than 5. But remember, when we're dealing with OR, we don't have to satisfy both inequalities. We just have to satisfy one. So anything less than 5, as seen in the bottom number line, is going to satisfy one or both of those inequalities. So our solution simply becomes x is less than 5.